Now lastly, we will look at significant figures. And whenever we do any kind of measurement, there's always some uncertainty in that measurement. So let's suppose this is our meter scale and these are in centimeters, but there's no further division between these. And we put this thing here, we match the left hand side and we match this. So it's going to be somewhere up to here, but there is no division. So what is the length? Well, we can say it's between 1 to 2 centimeters, between 2 to 3 centimeters, okay, somewhere between 2 and 3. And we can estimate, well, that would be around 0.5. So we can say it's somewhere around 2.6, somewhere around 2.7 or 2.8, somewhere around there. What we could guess that is closer to 2.7. So we can say, okay, that's 2.7 centimeters. But we know that this is in doubt. It could be a little bit bigger or smaller. We cannot and should not say that it's 2.72 or 2.65 or something like that, because we cannot estimate that closely on this figure. We just go to the first position or just divide this into 10 parts and just assume or just guess the best we can. We're noting that there is a doubt in this term. So this is, we say, two significant figures, and the last one is in doubt. So to improve the measurement, the only way to do that is to use a better instrument. And so we have another instrument here. Now this one has divisions in here. Well, they could be all over here too, but we're just looking at these. So it's 2.5, 6, and 7. So that's the 6 and that's the 7. So now we know it's between 2.6 and 2.7, somewhere between these two. And well, the line is sort of thick, so it's more beyond the half point of these two. We can estimate it to be 2.65, somewhat bigger than 2.65, 2.66 maybe, 2.67 maybe centimeters. That depends on the observer, how closely you can look at it and how closely you can estimate this. But this term, or this one, whichever one you may accept, let's just say 2.67, this is an estimated term, the last digit. So here we have three significant figures and the third one is in doubt. So what are significant figures? So let's suppose that the measurement was like this. Well, let's go back here. We could write this as 0.0267 meters. This does not make it 5 significant figures because the instrument, our measuring instrument, determines the significant figures. You cannot increase it from 3 figures to 5 figures just by converting from centimeters to meters. Okay, or you could write that as 26.7 millimeters. These are all 3 significant figures. So here, this is 2 significant figures. These zeros do not count. The zeros on the left do not count. These zeros do not count, but this 0 counts, okay, because that's in the middle. So this is 2 significant figures. This is 3 significant figures because the 0 in the middle is significant. Now, if you write it like this, you're saying that this is 0, so that becomes 3 significant figures. If we had put a 0 over here, that would have become 3 significant figures. This is 4 significant figures because we are claiming that this digit is indeed a 0. So whenever you take a measurement and you get a distance of 10.0, you don't just add another 0. Okay, you only add the 0 when you're certain that in this position it is a 0. Now numbers like this are ambiguous. So it's 1,500. Well, it could have been some counting of number of, let's say, tables in a room, or not a room, but in a big hall. And it's an exact number because you can't have a fraction of a table. Or it could be a measurement like 1,500 kilograms, in which case, yes, the last digit may be in doubt. But the second may also be in doubt. depending on how you're measuring it. So if you write it as 1.5 times power 3, then this is 2 significant figures. But if you write it like this, it's 3 significant figures. Whether you can write this or this depends on how it was actually measured to be. And if you write it as 1.500 10 to the power 3, that becomes 4 significant figures. But you can only do that if you're sure that that position is a 0. Now, when we're dealing with these figures, suppose we have this value. Okay, so we have a length that's 2.67, and this is, let's say, 1.02. So what is the perimeter of this whole thing? So we're at 2.67, that's the length, and this is to get 1.02. So it's 2.67 plus 2.67, these would be the two sides, and 1.02 plus 1.02. Well, we can just do this sum. Come to 7.38. Well, we're still in 3 significant figures, but let's suppose that this measurement was not 1.02 but just 1.0, and we do not have this digit, so it's only accurate up to here. Then it would be 2.67 plus 2.67 plus 1.0 plus 1.0, and so we would get 7.34. But can we write it like this? Because this is the 10th place and the 100th place is missing. This is the 100th place. So because this is in the 100th place is a certain accuracy, the accuracy here is only to the 10th place. By adding numbers or by mathematical manipulation, you cannot increase the accuracy. So because this is accurate only to the 10th place, the final result should be accurate only to the 10th place. And this is to the 100th. So we cannot write it like that. It should become 7.3. Okay, if these were all centimeters. So we should round it to 3 because this digit is only the first place of decimal, so we have the first place of decimal. So that is the rule for addition. When you're adding these numbers, we look at the decimal places. This has 1 decimal place, this has 2 decimal places, the answer should have 1 decimal place. Now let's suppose we were finding the area. So we have this thing 2.67 and let's say 1.0. Well, let's do it with both 1.02 and also with 2.67 and 1.0. Okay, a more careful measurement or more accurate measurement and less accurate measurement. So in the first case, the area is going to be 2.67 times 1.02. And that comes to 2.7234 centimeters squared. Now, our measurements were accurate to 3 figures and 3 figures. The result cannot be accurate to more than 3 figures, so we have to cut off here. And that becomes 2.7, well, this is less than 5, 2. That becomes the answer. So 3 figures here, 3 figures here, the result has to be 3 figures. Now let's look at this one, call this B. So the area of B is 2.67 times 1.0, which is 2.67. These are centimeters and centimeters square. Now this measurement is accurate to 3 figures. This measurement is accurate to 2 figures. The result cannot be more accurate than the least accurate one. So this has to be rounded 2.7 centimeters square. You cannot write it as 2.70, okay? That would be completely wrong because now you're making 3 figures. So it's 2.7 centimeters square. Now in this course, based on the textbook, we will have all results down to 3 significant figures. And if you're getting a result like this, 2.7234, and you leave it like that, leave it to 5 figures, you will lose a point for that. Everything has to come down to 3 significant figures. Now, sometimes you might have a figure of 5 over here, and you might want to keep 5. So, okay, 3 to 4 is acceptable, but more than 4, which is 5 or more, is not. So especially when you're using a calculator, suppose you want to find the area of a circle and use pi r square, the calculator has 8 digits or sometimes 10 digits in the calculator for pi, and your result will be in 8 or 10 digits. Okay. Always round that down to 3 or at most 4 digits. Okay, do not have more than that, more than 4 significant figures. So just a quick review, just over here for addition and also for subtraction, we look at the decimal places. For multiplication and also for division, we look at the total number of figures, not the decimal places.